Alright, good morning. Sorry I can't be here today, but we're going to run class just as if I was here. Just want to remind you about some expectations. First of all, that you are expected to behave better for the sub than you do for me. And in my mind, if something rises to the level that the sub has to write your name down on his or her report in a negative connotation, that's probably grounds enough for you to get a detention, and I will write you a detention if that happens. Um, so please be on your best behavior for the sub. Um, Also, some things I'm going to do. We really can't waste today, which is why I'm doing this, because otherwise you're going to be testing after spring break, and that's going to be no fun because we're all going to forget about it. So um, it's important that you pay attention during today, and to sort of keep you honest on that. What's going to happen is at the end of the period, the sub is going to give you a quick quiz. It's about 8 or 9 question quiz, um, and it's really is going to be, if you're paying attention today and thinking through what we're doing, it's going to be really easy. If you don't, then I I don't know. But my goal is that everyone gets 100% on the quiz because you're paying attention. Again, I'm not trying to trick you with it. It's going to be a bunch of really easy questions. All right. You should have picked up 2 handouts. You should have picked up the new set of warm-up sheets, and you should also have picked up page 107, which is called Type 1 and Type 2 ionic compounds notes. And with that being said, here is your warm-up question for today. Let's see here. I would like you to write the formulas using the crisscross method we talked about last class, or whichever method you prefer. I'd like you to write the formulas for these 3 compounds. And at this point, I'm going to ask the sub to please pause the video and set the timer for 5 minutes. And so I'd like you to just work on your warm-up quietly. Don't need to talk. Quietly by yourself for 5 minutes here. So again, will the sub please pause the video? Alright, let's talk about what you should have written down. So if we start here with magnesium phosphide, so remember the way formulas are written. So the first one's a cation, and so we have a magnesium here. And phosphide, remember the IDE is the end, but what it really means is phosphorus. So we've got magnesium and phosphorus. And then you can check on the periodic table, and when you check the periodic table, you should see that magnesium has a +2 charge, and phosphorus has a -3 charge. And then we're going to just do a crisscross here. And when we do the crisscross, what we're left with is Mg3P2, because the 2 from up here goes down here, the 3 from over here goes down there. So that is A. B, we've got potassium oxide, so potassium is K, oxygen is O, potassium has a charge of +1, K has a charge of -2, I'm sorry, O has a charge of -2. Okay, when I do my crisscross, I'm left with K2O, because the 2 comes down here, and the 1, remember we can put the 1 without any subscript. And then C, we have lithium and chlorine. Lithium's got a charge of +1. Chlorine has a charge of -1. When these 2 cross, I should be left with, this one's a boring one, just LiCl. Alright, now what I'd like you to do is get out the other handout you picked up. That's page 107. So go ahead and get that out on your desk. We're going to take some more notes today. And what we're going to talk about today is what's called type 1 and type 2 ionic compounds. And we'll talk about what that means in a minute. But first I need you to tell you that what we're talking about here is binary compounds. Binary compounds, and this is question 1, so I need you to write this down. Binary compounds are ionic compounds made of only 2 elements. So examples are here to the left, right? Sodium chloride, magnesium fluoride, aluminum oxide. These all just have 2 elements in each one. We're eventually going to be able to name compounds that have more than 2 elements, like this is ammonium fluoride. It has nitrogen, hydrogen, and fluorine. This is magnesium nitrate, magnesium, nitrogen, and oxygen. But we aren't doing those right now. So we're only interested right now in binary. So go ahead and make sure you have this written down here. And I'll give you a few moments to do that. Okay. Now, here's the difference between a type 1 and a type 2 compound. And this is what I need you to write down. So a type 1 compound is any that we already know the charge of. That is any in groups 1, 2, or 13. These are these 3 sections here. Again, section 1, or I'm sorry, group 1 we know has a +1 charge. Group 2 is a +2 charge. And group 13 is a +3 charge. So those we can deal with. We already know how to deal with these. What we need to learn about are what are called type 2 ions, type 2 compounds. Type 2 compounds, the cation is not in one of those sections. Instead, it's in this group 3 through 12 section. I'm sorry, 2 through 12 section, the transition metals. So write that down. Type 1 compound is from the cation is from groups 1, 2, or 13. Type 2 compound, the cation is a transition metal. Alright, let's focus on type 1 ionic compounds. And again, this should be reviewed for right now, but I need you to write this down, that again, the cation is from groups 1, 2, or 13. Write that down in the blank. Cation is from groups 1, 2, or 13. Now, what's the cation again? The cation is whichever ion is positive, whichever one comes first. So in a type 1 ionic compound, so this is the answer to question 3, the charge of the cation in a type 1 compound is always the same. And I'll get to what this means. It'll make a little bit more sense when we do type 2s. But in a type 1 ionic compound, the charge of the cation is always the same. You find it by looking at the periodic table. So just like we were doing in the warm-up, magnesium, you look at the periodic table, you find magnesium, it's got a charge of +2. Aluminum, you find aluminum on the periodic table has a charge of +3, and that's always true. How do we name them? Again, we've talked about this. You name it cation first, and then anion, except you change the ending to IDE. So you have something like, for example, the examples on there, magnesium nitride, beryllium oxide. So go ahead and make sure you should have questions 3 and 4 written down. If you need more time, I'll let if the sub would like to pause it if you need more time, that can happen, but I'm going to go on here. So let's do an example. Again, this is not new. This is what we were doing before. So what I'd like you to do is you can name all 4 of these. So the sub is going to pause the video, set a timer for 5 minutes, and you are going to work on these for 5 minutes. Okay, now that you've done these yourself, let's do these together. So magnesium nitride, again, we've got magnesium, and the nitride stands for nitrogen. Charge of magnesium, if I look on the periodic table, is +2. Charge of nitrogen, if I look on the periodic table, is -3. When I do my crisscross, the 3 comes down to be with the magnesium. The the 2 comes down to be with the nitrogen. So that's my answer for magnesium nitride. Beryllium oxide, beryllium, I look on the periodic table, has a charge of +2. Oxygen, look on the periodic table, I have a charge of -2. When I do the crisscross, I'm left with Be2O2. But that can't be the full answer because, again, we can simplify this, right? Whenever these two are the same, whenever the two subscripts are the same, I can cancel them out. And my final answer then would just be BeO. Okay. These are easy to name. So you got the first one, which is calcium. The second one is chlorine, but we got to put the "ide" with it. So this one we're going to call calcium. Let's see here. Calcium. Alright. Calcium chloride. And this one here is going to be sodium chloride. Oops. So that's type 1. Now we're going to talk about type 2 ionic compounds, which are new to us. But type 2 ionic compounds, and I need you to write this down in the blank there. In a type 2 ionic compound, the cation is a transition metal. What does this mean? Well, the charge, it's easy to figure out in type 1, it's easier to figure out the charge of the ion because you just look at the periodic table. But transition metals don't always have the same charge. You can't figure out the charge just by looking at the periodic table. So this is your answer to question 5, is that question 5 asks, what is true about the charge of the cation in type 2 ionic compounds? And the answer is that, that should say 2. The charge of the cation in type 2 compounds is not always the same. Instead, you have to know the charge by looking at the Roman numeral. I'll talk about what that means here in a second. But you need to write down the charge of the cation in type 2 compounds is not always the same. The cation so in question number 6, says how do you name the cation in type 2 compounds, and what you do is you use the cation, and then you name after you name the cation, you write the charge in Roman numerals. And I'm going to show you an example in a minute, but I need you to write that answer to begin with. And the other thing I need you to write down is that the Roman numeral, so this is in the bold statement on your paper, the Roman numeral tells you the charge of the cation, not the number of cations or the subscript. Just write it down for now. It doesn't really make sense yet, but as soon as I show you a few examples, this should make sense. I'm getting to the time limit of my video, so if the sub could just pause this here, and then when you're done with this, you can start playing the second video.